Hey guys, welcome back in. Mr. Marone here. Hopefully you're hearing me crystal clear with my brand new microphone. I feel like I'm doing a podcast here, not just a video, which is a little strange. So welcome back into our videos. This is our first video for topic 2, which is all about parallel and perpendicular lines. Wanted to just review a little bit of vocabulary before we jumped into all of the different concepts for this section, really what we're going to be living with over the next couple weeks. So just to review, when we talk about angles and we think about those angle pairs we reviewed, the first kind is we had adjacent angles, or two angles that shared a vertex and one side. And those look something like this. So there's angle 1 and there's angle 2. They share a vertex and then they share this ray right through the middle. If we have adjacent angles that also create a 180-degree angle, we call those a linear pair. And it's the same picture, only they create a straight line when they form their pair. When we have two angles whose just sum equals 180, they don't have to be adjacent. Those are known as supplementary angles. Once again, those don't have to be next to each other for them to still be supplementary. When we had two angles that shared only a vertex, and the textbook definition is whose sides form opposite rays, we called those vertical angles. And those looked something like this. If I had my two lines intersecting, angles 1 and 2 would be considered vertical angles because their sides form opposite rays. And then the last thing, the new topic or the new definition for us for this section is when we have two or more lines being intersected by the same line. That line is called a transversal. And an example of that is if I have this line here and this line here, the transversal will be in blue. It's going to be a line that cuts through two or more lines. So that's my transversal right there. In order for us to really begin with all of this, we do have to lay out the two main topics of the lesson, which are parallel lines and perpendicular lines. These are going to come out throughout the entire topic, through the whole chapter. Parallel lines are two lines that are never going to intersect. So think of train tracks. Think of the two yellow lines in the middle of the road when you're on the highway. Things like that would be considered parallel lines. And if you look closely, we've got the two bars next to each other, almost like two lowercase l's or capital I's. That's our symbol for parallel. So when you see that you've got two lines, say AB and CD, and there's that symbol in between them, that's telling you that they're parallel. The other one is perpendicular lines, and those are two lines that intersect and whose intersection forms a right angle. So an example of that would be something like this. That would be an example of perpendicular lines. And just like with our symbol for parallel, I've told you guys many times that mathematicians are super lazy people. So when we use the upside down T, that indicates that lines are perpendicular. So that's a whole big collection of all the different terms that we've learned for the most part. Transversal probably is a little bit new to you, but overall comfortable terms for us as we move into our idea of parallel lines and what that means for us. And our focus is really going to be on pictures like this, when we have parallel lines cut by a transversal. So when that happens, we end up having 4 different relationships that come out of this. So the first one is what are known as corresponding angles. Corresponding angles are in the same spot in their collection of angles. So if we look at this picture up here of our parallel lines cut by a transversal, you notice that I've got a bank of 4 angles created by that intersection there, and I've got another bank of 4 angles created by that intersection there. So when I say they're going to be in their group of angles, I'm referring to these two circles right there. So that bank of 4 in angle 1 and that bank of 4 for angle 2. Now, when we talk about corresponding angles are angles in the same spot in their respective group. So in this case, angle 1 and angle 2 would be considered corresponding angles. They're both in the top left of their group of 4. And the relationship that happens when we've got parallel lines, if lines 1 and 2 are parallel, then we have congruent angles. So the measure of angle 1 and the measure of angle 2 are going to be the exact same thing. One thing to note before we move too far on is if you notice there's these red triangles on the lines. That's another indicator of parallel lines. So they might tell us that they're parallel. They might say that line 1 and line 2 or line A and B are parallel. Or if they put these triangles on the line, they're going to indicate parallel as well. Our second pair are called alternate interior angles. So if you look up at the top, I skipped it unfortunately, but I'm going to come back to it. We've got some highlights here. So when it says interior, that means it's going to be between the two parallel lines. And then when it says alternate, it means it's going to flip over that transversal. Or in other words, one of the angles is going to be on the right-hand side of the transversal. The other angle is going to be on the left-hand side. So if we use that alternate interior angles, that means that my two angles are going to be between the parallel lines, and that one of them is going to be on the left, one of them is going to be on the right. Luckily, the names really tell us where they're all going to be. So in this case, angle 1 and angle 2 would be considered alternate interior angles. One's on the right-hand side, one's on the left-hand side of the transversal, and they're both inside the parallel lines. And that relationship is the same as corresponding. If you have alternate interior angles, angle 1 is going to be congruent to angle 2. It's a wonderful piece for us. Our third one is alternate exterior. So exterior means that they're going to be outside the parallel lines, and alternate means that they're going to flip over. They're going to have one on the left-hand side, one on the right-hand side. And just like the other two, just like corresponding and alternate interior angles, they're going to be congruent. The measures are going to be the same. Our final one are called consecutive interior or same-side interior angles. And that would be inside of our parallel lines, and since they are same side, they're both going to either be on the right or both on the left of the transversal. And this is the only pair that's a little bit different. If we think through things here, we know our alternate interior angles would be like angle 1 and this angle down here. So I could even put a little 1 right here, since we know those are going to be congruent from what we looked at above. If that's the case, if you notice, angles 1 and 2 together create a pair of supplementary angles. That's how we get this formula here, that angle 1 and angle 2 are going to be supplementary. So if you've got same side interior angles, they're going to equal 180 degrees. I know I just threw a lot of information at you. If you need to go back and review this or pause the video and write all of this down, that's fine. This is going to be a great spot for you to come back to as we move throughout our time together here. So let's take a look at some examples now of how these work. So if we're looking at this picture, they're talking about a snowmobile, and they say identify the pairs of angles of each type made by the snowmobile tracks. So if we were listing out our corresponding, the top left and the top left would go together, so angle 1 and angle 5. We'd also have angles, I'm sorry, let me switch these just so we have it. It'll be angle 5 and angle 1. So I'm using the top group first and then the bottom group. So then I'm going to work my way around. Bottom left would be angle 6 and angle 2. Bottom right would be angle 7 and angle 3. And then top right would be angle 8 and angle 4. If we then went to the alternate interior, alt-int, you can abbreviate to save your time. Remember, mathematicians are lazy. And alternate interior would be one on the right-hand side, one on the left. So angles 7 and angle 1, and those are once again going to be equal. But for our case, we're just going to say that 7 and 1. My other pair here would be my top left and my bottom right, or angle 6 and angle 4. For alternate exterior, I'm going to have my top left, which is angle 5, and my bottom right, which is angle 3. And I'm also going to have my top right and my bottom left, so angle 8 and angle 2. And then the last ones are the same side interior. SSI is our abbreviation for that. And those are going to be the two angles inside of the parallel lines and on the same side. So in this case, angle 6 and angle 1, angle 7 and angle 4. What I'd like you to do now, I'm going to stop the video, and I want you guys to try to name all angle pairs including the named angle. So in other words, I want all the angle pairs that involve angle 4 and all the angle pairs that involve angle 5. And you can just list out, such and such and 4 are corresponding, such and such and 4 are alternate interior, things like that. Go ahead and pause the video and give that a try. Okay, welcome back in. So as you can see, for each of these, I've had 3 pairs here. So 4 and 5 are considered alternate interior, and that obviously is the case for A and for B. And then I had corresponding, I had my bottom left and my bottom left, or my top right and my top right. And then I had the same side interior. Since they're in between these parallel lines, we had same side interior there and there. So we should have had 3 pairs that come out of each one. Now, our last example here, I'm going to step you through it. And here they want us to know how can we express each numbered angle in terms of x. So if we look closely at this, x is going to be, there's going to be 2 sets of answers here. So x is going to be the same measure as angle 1 because of corresponding angles. They're both in that top left spot. Once we move from there, x and angle 3 are going to be the same thing because they're alternate interior angles. And then x and 7 are going to be equal because they're vertical angles. They just share that vertex. From there, x and angle 2, so x plus angle 2, are going to equal 180 degrees. Those are same side interior. And then if you look closely, 2 and 4 are vertical. So we can say that angle 4 plus x equals 180. And if you notice that x and 6, they just create supplementary angles here. We don't have to use anything fancy. So we can say that angle 6 plus x equals 180. And then same thing with x and 8. They're just supplementary. So we can do angle 8 plus x equals 180 degrees. The neat part is, if you notice, there's only 2 answers. So the angles are going to be either one value or what's known as its supplement if we subtracted our original angle from 180. And you're going to end up having 4 angles that measure one, 4 angles that measure the other, and that's it for the whole thing. So you can solve the entire problem given one angle. I want you guys to try this one here. We're going to pause the video. You've been told that angle 4 is 118 degrees. If you want to use this list up here, these are the same angles. You just have to replace x with angle 5. Take your time. I'm going to pause the video and see what you can come up with for all of the other angles. Okay, welcome back in. So as you can see, I used my knowledge of the fact that 4 and 2 are vertical angles to say that this was 118. 4 and 8 are corresponding angles, so that's 118. And then 8 and 6 are vertical angles, or 4 and 6 are alternate exterior angles, so that tells me that's 118. If we do a little bit of arithmetic and we have our supplementary angles and we subtract the 118, we end up with 62 degrees. So 4 and 1 are supplementary, that means this is 62. 1 and 3 are vertical for 62. 3 and 5 are alternate interior for 62. And 5 and 7 are vertical for 62. So from given one angle, we can solve all 8 of them. That's it for this section. We're going to dig into some of the proof behind it on the next video, but I wanted you guys to just see the fact that we have these 4 angle pairs corresponding alternate interior, alternate exterior, and same side interior, and we're going to use these throughout the year. They're not going to change. It doesn't get any more difficult when it comes to their rules. So knowing these and really kind of honing in on these are going to make the next couple weeks in class really, really crucial. If you have any questions, please bring them into class, and I will see you guys all tomorrow. Have a great night.